Okay guys, so we're going to talk about net ionic equations, and they sound a lot more intimidating and they looked a lot more intimidating in your packet than they are in real life. So the first thing we need to understand is that anytime we put an ionic compound, like sodium chloride, in water, it doesn't stay together. So when we put this into water, it separates out and we get sodium ions that are dissolved in water, and we get chloride ions that are also dissolved in water. And this happens with any ionic compound that dissolves in water. So that means if we have something like sodium carbonate, remember sodium and then carbonate, and we know that carbonate has a -2 charge, so I need 2 sodiums to go with that. So sodium carbonate, this dissolves in water because that's a group 1. So when we put this in water, we get not 1 but 2 sodium ions and 1 carbonate ion. And remember, that's an ion all by itself, so it stays together. So both of these are dissolved in the water. Okay. So this is kind of the foundation for net ionic equations, is understanding that when we put 2 compounds in water, or when we put ionic compounds in water, they dissociate. So the net ionic equation part of it is trying to figure out what happens when we combine 2 ionic compounds that are dissolved in solution. So, first let's talk about what, in general, this kind of reaction, how it works. So in general, when we have what we call a double displacement reaction, then our ions are just trading partners. So we're going to take the example of sodium chloride, which we know dissolves in water because it's a group 1, and silver nitrate. And even though silver is not usually soluble because it's with the nitrate, it's dissolved in water. And we actually did this in a lab, and we combined these 2 solutions, and when we did that, they switched partners. So the nitrate comes over here and switches places with the chloride, and the chloride comes over here. And so now our new compounds are sodium nitrate and silver chloride. Now we need to look at our solubility rules, and our solubility rules tell us that this is sodium, it's always going to be soluble. But this is silver, and silver is not usually soluble unless it's with one of the 4 anions that are always soluble, and chlorine's not one of them. So we know that that's going to be a solid, and this is going to be aqueous. So that's step 1, is understanding how a double displacement reaction works. The step 2 is figuring out which one of your compounds is going to be a solid, if any of them. And if none of them are solids, then we write NR. No reaction. Nothing happens. Nothing changes. You're still just going to have 2 aqueous solutions. Okay, so let's talk about how we write a net ionic equation. Let's take a different example. I'm going to try and use a couple of different colors so you guys can see what's going on. So this is the example from your packet. So we have lithium carbonate. So we have lithium carbonate, and that's aqueous because the lithium makes it soluble. And then we have strontium chloride, SrCl2, and that's also aqueous because chlorides are usually soluble unless they're with certain things. Okay, so we have our 2 compounds, and we're going to do that same double displacement reaction. We're going to switch partners. So now we're going to have lithium chloride, we're going to have lithium chloride, keeping that in green so you can see where it came from, and strontium carbonate. Now we know the strontium's a +2, carbonate's a -2, so I don't need any additional coefficients or subscripts. And this is a +1 and this is a -1, so I don't need any additional subscripts, so I just need to balance my chemical equation. I have 2 chlorines here, so I'm going to put a 2 out in front of lithium chloride. That gives me 2 lithiums and 2 chlorines. I have 2 chlorines and 2 lithiums, and now my equation is balanced. Okay, so a couple of different ways to look at writing net ionic equations. I'm going to give you the simple way first. Okay, let's look at what our solubility rules tell us about these two compounds. So our solubility rules say anything with a group 1 element in the compound is soluble. So we're going to write AQ next to this compound. But then our solubility rules tell us that carbonates are insoluble. That's not a group 1, so that doesn't override that rule. It's not ammonium, so it doesn't override that rule. So we know that this one is going to be solid. Once we've figured out from our double displacement reaction what our solid compound is going to be, writing the net ionic equation is simple. Figure out what your solid is. I know that my solid is strontium carbonate. Where did it come from? Well, I have strontium in it, so I must have had strontium ions. And it has carbonate in it, so I must have had carbonate ions. And we go back and we write the states. This is aqueous, and this is solid. It's as simple as that. Now, if we want to talk about the longer and more complicated way of looking at these, this is what we call a complete ionic equation. So we started out with lithium ions, 2 lithium ions that were dissolved in solution, and 1 carbonate ion that was also dissolved in solution. And we combined it with a strontium ion that was in solution and 2 chloride ions that were also in solution. Now, after our reaction happens, we still have 2 lithium ions that are in solution. Nothing's changed with those. We also still have 2 chloride ions that are in solution. Again, nothing's changed. But now we have solid strontium carbonate. And that's changed. This is solid now. I'm not going to write it as ions because it's not dissociated. So this is our complete ionic equation. And if we wanted to turn this into a net ionic, we would simply go through and cross out anything that was on both sides. So I'm going to cross out the lithium ions. I'm going to cross out the chloride ions. And you'll notice that that leaves me with carbonate ions plus strontium ions, making strontium carbonate. This is the same equation as this. Whichever way works for you, that's the way to solve these problems. To me, this is a little bit simpler, but you do have to know what solid is being made. Okay, so let's look at one more example from your packet. Let's take letter A from your second page here. So we have iron 2 acetate. And, whoops, I left out the 2. And calcium hydroxide. And those are both soluble. And we're going to combine those 2. So again, we're just switching partners. This one goes here, this one goes here. So I'm going to wind up with iron 2 hydroxide and calcium acetate. Now, use your solubility rules. There's no rule about iron, but there is a rule about hydroxide. And the hydroxide rule says that they're insoluble unless they're with group 1 or heavy group 2. That's not group 1 or group 2, so this must be a solid. We have a rule about acetate that says that it's always soluble. So we know that that's aqueous. So we're going to go back and we're going to say, okay, I know that my product is iron 2 hydroxide. What came together to make iron 2 hydroxide? Well, iron ions and hydroxide ions. We're going to go back and we're going to write their states. And we're done.